trigonometric function isolated. That's exactly what I want. Okay? So you guys can see in the other problem, they're not isolated. So guess what you're going to have to do? Apply algebraic operations, right? Or arithmetic operations to isolate the trigonometric value. It's all algebra 1. This problem, I'm going to do the easy one. Sorry, but that's just the way it is for today. So here, it's already been isolated, right? So it's cool. But just maybe an FYI, could the problem have been written like this? And then you could have done some manipulations, right? OK, I mean, we don't need to do that many examples. I think you guys get the idea. So now we got to figure out, well, when is sine of theta equal to the square root of 3 over 2? Crap, got to know the unit circle. So we go to here and here. And we'd say pi over 3 and 2 pi over 3. Yes, right? At least this coordinate point we know, guys, is 1/2 comma square root of 3 over 2. Right? So would you guys agree with me that sine is positive in the first and the second quadrant? So those are the two values? Yes? OK. Now again, for A, we're trying to find all the solutions. Well, these solutions, you guys can see, they don't really have any relationship with one another. Like they're not an equal distance away from each other. So what we're going to have to do is just take each solution. Theta equals pi over 3 plus 2 pi n. And theta equals 2 pi over 3 plus 2 pi n. And if you just keep on adding or subtracting 2 pi to those angles, you're always going to get an x-intercept. Yes? Yes, no? For B, it says find all of the solutions between 0 and 2 pi. Well, that's just kind of like the general unit circle, right? So if you just like imagine just the unit circle, like what are the solutions? Well, that one's kind of easy. I'm going to use set notation here. You don't have to. If you want to continue writing theta equals, then that's fine. But you can write them as theta equals, the angle equals, or you can write them as a set notation. That's fine. And then C. C is find the angle that satisfies 0 to negative pi halves. So again, let's think about that. That is from 0 to negative pi halves. Is there a solution in that quadrant, that fourth quadrant? Yeah. What is it? Let me ask you this question. Is sine ever positive? Because sine has to be positive, right? No. Is this ever positive in the fourth quadrant? No, it doesn't exist, right? It can't exist. Fourth quadrant, y coordinate's negative. Sine is the y coordinate, which in this example is positive. Do you guys kind of see that? Right? See how that? So it doesn't work. So guess what? It does not exist. There is no angle that falls within that constraint. Does not exist. Or you can say no solution. OK? Now, the important thing is, so I can play around with that restriction, guys. I can have fun with it. Right? What if I change the restriction to be from pi halves to pi? Then what would your answer be? What if I said the restriction is from pi halves to pi? Then theta would have to equal what? Pi halves to pi. 2 pi over 3. Right? So we can have fun with this. I could also do from 0 to 4 pi. And then you'd have to do one extra revolution. So it can get crazy. For today, we're just going to focus on 0 to negative pi halves. OK? All right. So I'll have my first two groups here.